Hi YouTube, continuing question 7, complex algebra, further pure 1, 2012. Given the complex number z, to find the argument of z in A, z plus z squared in B, z plus 7 over z minus 1 in C, and given that w equals lambda minus 3I, and the argument of 4 minus 5i plus 3w equals minus pi over 2 to find lambda in D. So for part A, tan theta is imaginary over real. So tan theta is root 3 over 2 in the fourth quadrant, giving minus 0.71. So for z plus z squared in B, applying using the complex number given, simplifies, and we can read off that A is 3 and B is minus 5. So for part C, applying and considering multiplying by 1 plus root 3i top and bottom, simplifies, and we can read off that C equals 3 and D equals 2. So considering the value of lambda in D, substituting w into the argument expression and simplifying, then we can write the argument as 4 plus 3 lambda minus 14i equals minus pi over 2. And considering equals minus pi over 2, the real part of the argument will be 0. Then evaluating gives lambda equals minus 4/3. So the argument in A, z plus z squared and z plus 7 over z minus 1, and solving for lambda. So question 8, a rectangular hyperbola. We're given the expression for the hyperbola and a point P to show that the equation of the tangent is this expression in A. And then we're given that the tangent crosses the x and y axis at A and B, and given that the area of the triangle OAB, where O is the origin, is 36, to find the value of C in B. So given the hyperbola equation and the point, differentiating the hyperbola equation implicitly gives the gradient expression as minus y over x, and using the coordinates of P, then minus c over t divided by c over t will give us an expression for the gradient of minus 1 over t squared. Then applying the straight line formula with our point simplifies to the proof required. So for the exact value of C and B, considering the triangle OAB, and as it crosses the axis at these points, substituting in the tangent equation, we can write down coordinates for A and B. And considering the area as 36 and the height will be 2c over t, applying the area formula gives 2c squared, and evaluating with 36 gives the exact value required. So our gradient and the tangent. A final question in this paper, question 9, matrix transformation. We're given the matrix M to find the determinant in A, and the transformation M maps S onto S dash to find the value of A in B. And then we're given the coordinates of R as 6, 0, and given that O is the origin to find the area of ORS. And then ORS is mapped onto OR dash and S dash by M to find the area of this triangle. And then given the matrix A to describe the transformation represented by A, and B is followed by A, is equivalent to the transformation M to find B. So for part A, applying for the determinant equals 0 gives minus 23. And for part B, considering M maps S to S dash, applying row 1 gives 6A minus 21 plus 4A minus 4 equals 25. This gives A equals 5. So considering the area using the result of A equals 5 and substituting in S gives the coordinates as 3, 4, and given R is 6, 0, considering the height will be 4 given the coordinates, then we can apply the area formula to give 12. So for part D, considering ORS is mapped to R dash, S dash by M, we can use the determinant of M with our area to give 276. So for the final, for part E, the transformation A, from observation we see it's a rotation of pi over 2 anti-clockwise. So considering B for the final part, as M is represented by A followed by B, then B multiplying both sides by the inverse of A, B will be the inverse of A times M. So applying the inverse of A, considering the inverse of A and applying the inverse of A times M gives the required matrix for B. Thank you for watching. I'll start further pure 2 in the next video.